So this is the reaction mechanism for nucleophilic substitution. Specifically, we're going to do it for the reaction of hydroxide ion with a general haloalkane. So we start off with the haloalkane, which will draw like this. Okay, the R groups, and we'll see these a lot in the reaction mechanisms, are just there to stand for a hydrogen atom or sort of any alkyl group. They're not going to take part in the chemical reaction. To finish off the haloalkane, we're going to use the symbol X to represent any halogen. Okay, typically that would be a chlorine or a bromine. Those would be the usual examples for A level. Now, with the haloalkane, it's good to note for the mechanism that there is a permanent dipole. The carbon is much less electronegative than the halogen is going to be. So the electrons in this bond are skewed towards the halogen. It has a delta minus charge. Okay, now we need the nucleophiles to say, particularly we're going to use the hydroxide ion. So it's the OH ion. It's got a lone pair on the oxygen. Overall it's a negatively charged ion. And that lone pair is very important. So to show the mechanism, we need to start an arrow at the lone pair, that's the electrons, and put the arrow to where they're moving to, which is close to the carbon in the carbon-halogen bond. That forms a dative covalent bond, but if something doesn't change, it would mean the carbon has 1, 2, 3, 4, 5 bonds attached. That's not allowed. So as the hydroxide comes in, the covalent bond has to break, and the electron pair that make up the covalent bond will move to the halogen atom. Okay, so which will change the molecule. So instead of being bonded to an X, a halogen atom, there'll be a new bond formed. That red arrow showing the electron pair joining with the carbon, and there will now be a halide ion formed. So that lone pair has come as a result of the electrons in the carbon-halogen bond moving to the halide atom. Points to note: the arrow here must start on the lone pair, and here the arrow must start on the bond. The arrow must show where the pair of electrons is moving. The lone pair is moving here, the bonding pair of electrons are moving there.